I am going to switch from doing this, although this is good. We're making some progress, but I'm going to switch to doing TIS-100 for a little while. So if games about assembly language distress you, then look away. But I am up to this one. So this is a game by Zachtronics, which is I'm trying to complete. And I'll link it here. TIS-100. I have a bunch of these games on my Steam, and it's 50% off at the moment. It's very cheap to buy. I have a bunch of these games on my Steam that I haven't finished, so I'm trying to finish them. But I highly recommend it if you like puzzle games. Basically, a relative of yours dies, and they give you one of his old computers, and it's got a bunch of cryptic notes left on it that you have to kind of decipher as you repair it. This one, for example, his name is Uncle Randy, and this one is, when I get into a groove working on this machine, it feels like I'm in the presence of another being, a being that understands me. Forget about all life that pains me and drags me down. I want to be a tessellated intelligence. Take the inputs, process, perceive, understand. I think the general idea is that he's just devolving into madness as you go on. It's kind of cool. A bunch of games on Steam that you haven't finished. What a rarity. I know, right? I have over 1,000 keys at this point, and I'm pretty sure I own but haven't redeemed. What? I want to play all of the games in this series because he did a whole bunch of them. Space Cam is another one. Shenzhen IO is another one. Yeah. Oh, I should turn desktop sound on as well. There we go. Yeah. So this one, I've completed. Where are we at? Return to the segment list. We've gone all the way through all of these, and we're up to sequence reverser. And Ted is sleeping through the whole thing. Good boy. Okay, sequence reverser. Create new program. This one will probably be my fail because they seem to be getting harder and harder. I'm definitely reaching my skill limit. Not including games you haven't played that you did redeem. I've been part of the Humble Choice monthly bundle since the start. Interesting. You get 12 games for like 13 something US dollars after tax. You just can't bring yourself to cancel it. I didn't know that was a thing. That sounds really interesting. But yeah, at some point you run out of the ability to play them, right? Okay. Sequences are zero terminated. Read a sequence from in, reverse this. Oh, this is going to be hard. Reverse the sequence and write the sequence to out. And we've got memory nodes. Now the game comes with this cryptic sort of pseudo paper manual, which I don't have open right now. Let's open that up. Ramen completed. Cha-ching! It comes with a note from your auntie. It's kind of cute. But there are memory modules. These memory module things are new to me. Stack memory nodes. So yeah, I need to understand what those are. Basic execution node. Stack memory node. Enable read-write access to a large number of values according to a simple stack-based communication protocol. All interaction with the stack memory nodes is performed through ports. Writing to the node adds the value to the top of the stack. Oh, so we could use the stack to reverse the thing. If the stack is full, the write will block until space becomes available. Reading from the stack memory node removes the top value from the stack and produces that value. Sure. If the stack is empty, the read will block until a value is available. Okay. Typically connected to multiple other nodes, any connected node, simultaneous reads and writes resolve in an undefined order. But each individual communication will behave according to the described communication protocol. For more information on using storage nodes, refer to the separate document Tessellated Intelligence System, blah, 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 which we don't have. Okay, stack memory nodes. All right, cool. This could be interesting. So I have to get the numbers here, read in, reverse, and write out. Well, if this is a stack, surely we can just use the stack to reverse the numbers, right? Okay. Let's start. Let's try move up ACC. If it's 0, which is the terminator, which you'll get there, then we're going to go jump equal to 0 out. Out will be probably reading a bunch of values from the stack in the reverse order. So this is, I'm not so scared about this one. You sent me a pic because the Raman law must be fulfilled. I'm honored that you would trust me with such a thing. Hang on. I'm just going to make sure it's not like something. Oh, okay. I concur. The Raman law must be fulfilled. How can I do this? Hang on. I believe in the Raman law. The Raman law. It is true. We have seen. The dog sleeps on. Okay. Now. Okay, so we're going to read, we're going to move everything in. Let's call this B for beginning. Mov ACC right. Jump B. And then our out procedure will be mov right down. I should say move, really, but I can't stop saying mov. Oh, what happens? How do we know about the end of it? Ooh, that could be interesting. How do we detect the end? When do we stop moving things down? Do I need to have a counter? All right. I hope you sleep. I definitely think you will. Good night. If the stack is empty, the read will block until a value is available. No, that's not good. We don't want that. We only want to read a certain number of times. Oh, this is going to be... I guess I could put the reader down here. No, but I have to wait. I have to trigger reads somehow, and then just read and read and read and read and read. Okay. I can do that. Let's try this. Let's try a signal. If we read a 1 from here, signal reads. If we read a 1 from there, we're going to read everything from up here. But how will we know when to stop? It's the same problem. Unless we count the length, which we could also do. So this could be a length counter. And it could keep track of what the current length is. And then we could read exactly that number of things. Yeah, I'm okay to go with that. I think we can go with that. I think we can at least try it, right? Let's give it a go. Let's give it a crack. Because I don't think you can just read and then block. I don't think that's going to work. Yeah, okay. All right, all right, all right. Get rid of that. We might not need that. Jump equal to 0 out. Move ACC right. That is correct. And then move 1 left, because we're counting 1 for each number. And jump B. Yep, and this one will be move right ACC, or actually just add right. Add right. And then, except we should probably, we have to have a way to clear the counter. So maybe if it gets 0, yeah. Okay. Okay, I think we can do that. Move right ACC. Or actually, we don't even need to move 1 left. We just use move ACC left, and then if it's 0, it'll be good. We might just need to put it before the jump. Yeah. Okay. So move right ACC, jump equal to 0, reset. And then reset will be sub. No, actually it'll be a 0. So just go save. Yeah. And if it's not, then we go swap, add 1, save. Or we could just swap again. And move B for beginning. Yeah, something like that. Right, jump B. Okay. So grab the number. If it's 0, reset everything by zeroing out the... Oh, before we do that, we need to send it back. So reset is swap, move ACC right, swap, save. Yeah, I think something like that. I'm just worried about blocking between these two read and writes, but we'll see how that goes. Move ACC left, jump equal to 0 out, move ACC right into the stack, and jump B. Out is going to be move I think move the count down. So move left down. To get the count into here, and then we go move up right, and then this will be our memory dumper essentially. This will be move left ACC, move, if it's a 0, then we'll just jump back to the beginning again. Otherwise, move up. How do we do it? We have to have a loop. Move up, down, sub 1. Jump equal to 0, B. Loop. Let's move up, down, sub 1, jump equal to 0, B. Jump, loop. Yeah, something like that. And then move up, down. Okay, so move left down gets the count down here and stores it here. And we just keep subtracting until we get to 0. I have no idea if that's going to work. Let's just try it. So 22 is our first. Okay, so far so good. $43. We've got 96 to come, and that should be our last one. Okay, so does our end detection work is the next question. Jump equal to 0, out. Move left, down. Okay, so our length is 5, and we've got 5 numbers, so that's good to start with. Okay, so now we should start pulling things out. Move up, down. Okay, that's our first failure. So why did we get a 14? What happened there? I missed the 14. How did that happen? What? Wait a minute. Okay, I need to run through until... I don't know what happened there. Let's stop that. I missed whatever that was. I thought for a moment we were going to get a win on the first try. All right, so this is the breakpoint there, so let's run to that. Jump equal to 0, B. Oh no, that's right. Where did the 14 come from? What the hell? Okay, I'm obvious. Oh, right. This one here. Oh, I see. So we've got to stop until... Oh, yeah, this isn't going to work. We've got to stop because we keep adding numbers to the stack. All right, cool. So one approach would be to actually move the 0 onto the stack, and then we'd know to ignore it. That could work. But I think it's probably better if we just stop adding numbers to it until... Yeah, so we might need to move this stuff up here somehow. Huh. Okay. Let's see if we can actually make that happen. We might not have enough room. So out is going to be mov left ACC. Jump equal to 0 B. Loop is move up, move right down. We'll just call it L. Move right down. Sub 1. Jump equal to 0 B. And jump L. Okay. So that means we can get rid of this and we can move left down. I have this feeling that you could actually do it much simpler, but I don't know how. I think if you put it in here and just read it out here, and then just had some code in one of these boxes that emitted all the zeros. Oh wait, you're supposed to emit the zeros. Ah, what am I doing? All right, this is way more complicated than it needed to be. Let's just make sure that I'm not being a total idiot. Let's do it. Move up, right. Move up, down. Move up, down. Let's just try that. No. Okay. All right. All right. So that definitely wasn't it. Just out of curiosity, what does it do? So you get 22, 22. Oh yeah, no, that definitely wouldn't work. Okay, cool. I'm not being a total idiot. That's all right then. Stop. Can I undo this? I hope. How many undo steps do I have? Okay, cool. I was thinking, am I just overthinking it? Is it just not that simple? All right, let's try putting a breakpoint here, and we'll just run through. Okay, 43 is coming back in. 98. Oh yeah, this is going to work. Except the 0. I need to deal with the zeros. Okay, jump equal to 0 B. So we're not storing the zeros, and we just need to emit a 0. So jump equal to 0. We'll just call it 0. Jump equal to 0, 0. Or end, I guess. That's a better name. Move 0 down. And that should be enough in theory. Okay, let's try that. Yeah, that's going to work, I think. Interesting. Let's try a run through. Cool. No, stop. Okay, that was bad. Let's get through to that place. Okay, why? Oh, it's not handling 0 length. Interesting. It's not handling single length. Right. Yeah, that didn't work. Okay. Oh, no, that worked. Zero worked. Yeah, I think it's gotten confused. So the handling of the zero length sequence is bad. But that's the only thing that's holding us up, I think. Is it ever going to output anything? Ah, yeah, there we go. Okay, so yes, definitely we need to figure out what happens when you just get a zero straight up. So we've got jump equal to 0 out, and we've already moved it left. And we've moved it right. Oh, no, we don't, because we're jumping to here. Move left ACC, which is going to be 0, I think. All right, let's put the breakpoint here instead. All right. Okay, so now we've got 0 on the way in. All right. We've got 19 on the way in. This one is moving the accumulator right, which is going to be 0. It gets put there, and we jump equal to 0 begin. Okay. That is not a good instruction. But we kind of need it, right? Like, do we? Maybe we don't. What happens if we take this out? It blocks. All right. Because there's nothing in the stack. Right. So maybe we do need to put the zeros on the stack. Or maybe we'll just push one onto the stack. Move left ACC. Move 0 right. And then we go move right down. No, we can't do that because it'll be the last in, first out. Shoot. Maybe I should just push an artificial 0 in before everything else. So the end of the last sequence is the beginning of the another. It would fail if the 0 was the first thing, though, but I guess that's not a huge deal. Maybe. Let's find out. Move left ACC. Move 0 down. Move 0 right. This is probably bad. Let's just see what happens. It's all zeros. Yeah, no, that's not going to work. All right. So move left ACC, and if it's 0, What about jump equal to 0 end instead of B? Yeah, that might work. Ah, here we go. Here we go. All right, cool. I think we cracked it. Let's get rid of that breakpoint. Here we go. Let's see how many red things we get. It's looking promising. It's looking promising. Yeah, I think that'll do us. So using a counter, huh? I wonder if I could have found a solution without the counter. I bet I could have. Okay, well, we got there anyway. Okay. Return to the segment list. We get a new unlock. Signal multiplier. Okay. Tuesday. How you doing? Shout out Tuesday. Oh, hey. Hey, that's my line. If anybody doesn't, well, you're possibly one of two viewers at the moment, but if anybody doesn't know Tuesday, that is her stream and she does awesome art stuff. I'm sorry, I'm assuming gender. Signal multiplier. Create new program. I don't know if I do. Do I? I got a different thing for my mic. I'm doing all right. I'm doing okay. My partner's not well today, so she's at home sick, and I am hanging out with the dog in here and playing this ridiculous game about assembly language. Let's see what our communication failure is this time. Debug. At first, I thought the TIS-100 was esoteric and strange, but the doing makes so much sense once you get it. It's like it was designed by a different kind of intelligence, completely different from the computers we know, but familiar too, in a way. I don't believe in New Age bunk, but I can't help but think it's getting garbled. It's almost as if it came from a different universe. We're getting into the alien side of things. Okay, fair enough. Randy is devolving into madness, I believe. I hope she gets better and you love the dogs. And yeah, interesting game thing. Yeah, it's kind of weird, but it's a puzzle. I like a puzzle. We love aliens. We do. We do love aliens and alien computers. Okay. Read values from NA and NB, multiply the values, and write the product out. Ooh. Okay. I'm guessing I have to use these nodes. So I would have to push them both in, and then, how do I do that? Where's that manual thingy? Is there a multiply or is it just add? Any last blah blah blah. We can do add, sub, neg, jump, JEZ. No. Okay, I might have to figure out how to do multiply. That could be hard. How would you do multiply if you don't have the ability to multiply? You'd have to loop n number of times, adding the other number each time. Hey, Just Sophie, how you doing? Justo Sophie. I'm mispronouncing. I always appreciate Clonk's stream because he manages to correctly pronounce every single person that comes through down to the letter. Sorry for the hard name. You're allowed. It's fine. It's not a hard name. Everyone always asks me how to pronounce my name. I should have just spelled it B-C. Doing some bevy here. Also nice. I've just finished some bevy stuff. I finally got my game running again. So I was like, right, I have to sit down and work on the actual game and not just do all this streaming stuff. So I dug it out and got it running again. And it's getting very late now. I'm on Sleepy Angel. I just wanted to say hi. Your voice is very soothing and relaxing. Thank you for streaming. You're so cool. You're cool. You're cool. No, you. You're rooting for me. Thank you. And I appreciate you stopping by. It's very nice of you. What's your game genre or theme? I can show you. It's in very basic state. But it's a top-down kind of resource management kind of crafting survival type thing. See you soon. Absolutely see you soon. He's a bit colorful at the moment because I was doing Adam Eunice's tutorial about 6-direction or 8-direction animation, and he suggests coloring all the limbs differently. But yeah, it's just hex-based harvesting and crafting and stuff, but with a story. So yeah, that kind of thing. Still in obviously a very new state. But I'm a beginner, so I'm allowed. Now, we need to figure out multiplication. This is interesting. So, mine's also very to-do. Yeah. Yeah, well, I think, and using Bevy, it's I think a lot of the stuff I've been doing on the stream is just trying to figure out how Bevy works and trying to make it learn more about the internals and get better at it, get more fluent at it. Okay, so I think what we're going to end up doing is storing both values, then retrieving the first value. Yeah, how are we going to know? How are we going to know when to stop pulling values out of the stack? Interesting. I guess we could write... Oh, yeah, that's cool. We could write the value to the stack X number of times based on the first number, and then just add them all as they come back out with a terminator, like a 0. We never... Oh, no, the 0 is in the queue. We can't use 0. Damn. 0 times 4 needs to be 0. Okay. Okay, let's try just getting them into the stack first of all. Move up, right. Move left, down. Move up, down. And then how are we going to tell? I guess you just take 2 numbers each time. And then move up, right. Move up, right. And so here... No, actually, you don't have to do that. What you could do is move up ACC and then loop. So you could say, let's label that B, and then L for loop. Move up right and sub 1 so that we've done it once. Jump equal to 0 end, or actually B, and then jump loop. So we're saying we're going to store the first number, and we're going to keep moving the second number into here until we're done. So actually we won't jump to B, we'll jump to end. And then end can be we need the number again. We need the, what do you call it? The numerator, I guess. I don't know. The first product, the first factor. Math is not my strong point. Okay, so move left, ACC, move up, move left, move ACC down, move up, down, move ACC down. So we get it again. Then we can go, oh shoot, we can't. How do I do this? This is going to take a while. You're still awake? No, go to sleep. Go to sleep. You're so wired from thinking about all the things you've been doing during the day. So end. I can't. I suppose I could use save. No, I can't. Like, I can't. I have to do it n number of times. I think I might need to move up, down, so that we pass the number of times down into here, and then we go move up ACC. We do the calculation in here. All this is responsible for is move up left. So it just cycles things out of the memory stack. But we've got a counter. So we can go loop, move right. No, I still can't do it. I need to be able to manipulate two values at the same time. How do I do that? Good night again. So I can put the number of values into the memory node that I require. But how do I know when to stop reading from the memory node? Maybe I could use an additional 0 as a terminator. Let's think about this. Going to have some ads floating through in a sec. Okay, so end would be move 0 right. And then this could be add up. Jump equal to 0. No, hang on. This is confusing. I don't think we can use 0 as a terminator either. Because how do we add something, but also check to see if it's, I guess we could swap, right? Hang on. So move up ACC, jump equal to 0, end. Otherwise, swap. But that puts whatever you've just moved into the store, so you don't have access to it anymore. So you need 2 copies of each thing, basically. Would be the the lame way of doing it. There must be a way to do this. How do you add something and loop at the same time? The loop indicator has to be in ACC because you have to be able to subtract from it. You could store the subtracted. Yeah, maybe? Let's take it out of this context. Could you keep the thing, the loop indicator, the loop index, could you keep that in the store and just keep the other thing in ACC? End could be move up ACC, save, and then you would need to loop again. L2 would be move right, or just add right. Or I guess you would have to move 0 ACC. And then this would be add right, swap, sub 1, swap, jump equal to 0. Actually, no, we would jump on the counter. Jump equal to 0. I don't think this would cover the case where it was 0, but let's just figure it out. Jump equal to 0, B? Or out, I guess. I definitely think we're not going to be able to fit all this in. And that would be jump. L2. And out would be move ACC down. That's not it, though. Just out of curiosity, what does it look like running? That's definitely wrong. Okay. I kind of think that multiplication thing might work, though. The only thing it's going to break on 0. 7 times 0 is 0. That's not going to work. I wonder if I'm supposed to use both of these stacks. I don't see why I would, though. I think the first thing you've got to have is a case for handling 0 as the first number. So move up ACC, jump equal to 0 out. Jump equal to 0 is 0. 0 is move 0 down. So that's the first thing, because it's a nice easy win. And then we've got to move the move up. This is our loop. So L, move up right. Sub 1. Jump equal to 0. Out. Or end. And end could actually be sending it somewhere else. Like, we don't have to do it all here. Jump L. End could be we could just move. We could move all of the numbers, including the first number, across to here and multiply. I think this would have to become move any down. But that's okay. Move up left. No, we need to know how many times to move across. Also, if that first number is 0, we need to consume the other numbers. Move up ACC, move up ACC. This is going to be 3. And then our counter needs to yeah. Need a drink here. This is going to be tricky. Okay. I mean, the other thing is we could only deal with the 0 case in here and then deal with the rest of it in here using this memory node. And that would give us the space we need. Yeah, why don't we try that? Move up left and move. Oh, we also need to handle the case where the second one is 0. Oh. Okay. Damn. This is so inflexible. But 0, 1. And okay, so move 0 down, move up ACC. Jump B. 0, 2. So inflexible. Move 0 down. Move up ACC. This is 0, 1. Move up ACC. We can't. Yeah, we have to move it left. Oh, this is so hard. This is so hard. What do I do? I can't multiply. So I have to rely on... adding. Okay, I think this is unnecessary. We don't jump equal to 0. Move up ACC. Well, we do jump equal to 0, but we don't move anything into the stack if it's 0, right? So if the first number is 0, we just don't multiply it. L. Hang on, let's make that B. L is move up right, jump equal to 0 end, sub 1, jump L. End is move up ACC, save, it would be tempting to put the numerator on the stack, and then you could get it out again down in here. Yeah, I think that's what we're going to try. Okay, so move up right. All right, so if we run through that real quick, we should get but no, because we need to know when to stop. No, we can't do that. Painful. Painful little process. Much like the stream. How do I do this? I have to move it back out in this direction, don't I? I need ways to make better use of more of the boxes, essentially. I could load it using this. That would free up more instructions. Oh, apparently copy paste doesn't work. Move left down. And then this becomes B. Move up ACC. Loop. Actually save, then loop. Move right, no, add right. But you don't want to do it once if it's 0. So swap, jump equal to 0 and no, because it's only been added once at this point. So this is wrong. Okay, here we go. This is going to be good. B. Move left ACC. Loop. Jump equal to 0 end. And actually, I don't know if there's anything in the end, but let's figure it out. Move hang on. We need to save and swap here. Move left ACC, swap, or save, either one. Move left ACC. All right. And the loop is swap, jump equal to 0 end. End is move 0 ACC and save, just to zero everything out. If it's not 0 in the store, then we sub 1, swap, move ACC down, jump loop. let's not even do anything more than that. Let's just see if that works. So we've got 8 and 1. And 1 is the counter. Subtracting 1, swap, move it down. Jump to the beginning. Swap. Jump equals 0 end. 0 out both values. Yeah, that's correct. Okay, cool. Cool. All right, let's try seeing what this looks like. So begin is move up ACC. And that's our counter. So we're going to save and go to our loop. Swap, jump equals 0 end. Sub 1, swap, add. Actually, I don't think that'll work because we could have a non-zero value in there. So we might go move 0 ACC, just to start with a 0. So sub 1, swap, add, right. Jump L. End is move ACC. The only thing that this doesn't cover is if I'm just wondering if there will be anything in the stack if it was 0 times something or something times 0. I think there might be a string of zeros if it's something times 0. We'll just have to see. End is move ACC down. Move 0. Actually, I don't think we need to do that. I don't know. Let's see what happens. So we should start with 1 and 8 in the stack, I hope. Okay. First of all, we subtract 1 from the counter. Then we swap. We add right. Jump L. Swap. It's a 0. We go to the end. We move it down. No, that was wrong. Okay. It should have been swap, move ACC down. Let's put a breakpoint there. Okay, the first one was correct. And the second one. This will be interesting. Hey, it was right, but I'm sure that something times 0 will break. Okay, here we go. Did that just work? Oh, hey, it's going to work. All right. All right. I thought this was going to be harder. It was still pretty hard. I'll probably come up across a case that I haven't covered. But so far, looking pretty good. Looking pretty good. Wow. I did not expect this to work. It's probably not the most efficient approach, but I'll take it. That's cool. Certain kind of beauty to it, I suppose. Well, I think we can confidently say this is going to work. I wonder, would 0 times 0 still work? Probably not, right? Oh, here it is. It's there. So we get to find out. It did. All right, sweet. I'm happy. Multiplication using addition. And I wasn't even like that badly on the cycle count. So that's pretty good. Most people apparently used the solution I did. Okay. Whew. We're getting there. I keep thinking the next one's going to be the hardest ever, and I don't know if it's true. Okay, what do we got here? We're all the way up to stack memory sandbox. I'll just have a quick look, but yeah, it's just test run. We don't need that. Image test. Oh, I heard about this. This could be interesting. We've unlocked all these bottom ones. Excuse me. All right, create new program. Fill the image buffer with the specified target test pattern, and the target test pattern is all white. All right. What's our debug for this time? Back from the hospital. The hospital got a bunch of tests done. They don't know. They don't find anything wrong, maybe? Strange. I could have sworn I heard those I'm going to assume that's voices. I brought the TIS reference manual with me to look at the image processing part again. It looks like compression, maybe? Still can't believe it's something. This thing was way ahead of its time. Wow. Okay. He's in the hospital. This is not good. He's hearing voices. This machine is taking him down slowly. All right, so we have to go back and look at our manual because I can't remember if there was anything about the images. Stack memory node, random access memory node. We haven't even seen any of those. Figure out who sold TIS dealer to swap meet dealer. Renew license plate tabs. Debugger, breakpoints, visualization module usage. Here we go. Okay. The TIS-100 contains a visualization module that allows programs to programmatically create and display images. The module contents can be modified by sending command sequences, which consist of the starting X coordinate, starting Y coordinate, one or more color values, and a terminating negative value, often -1. The coordinate system starts at 0, 0, which is located in the top left of the display area. The visualization module supports the following colors: 0 black, dark gray, bright gray, white, and red. The visualization module resolution, 30 characters wide and 18 characters tall. The image console sandbox contains a larger visualization module that is 36 characters wide and 22 characters tall. Draw a single white pixel in the top left corner of the module's display. Okay. Draw a horizontal red line in the top left corner of the module's display. So 0044444. I don't get it. Wait, so the last character is always the color? Wait a minute. Starting x coordinate, the starting y coordinate, one or more color values, and a terminating negative. I see. Okay. So 0044 is x and y. Wait, what? The starting y coordinate, one or more color values, and a terminating negative value. So 00 to 44, and then we've got 3 more 4s. Interesting. I might need to play with this a little bit. Okay. All right. Let's see where we get to here. Fill the image buffer with the specified target test pattern. So what happens if I just go move 0, 0. Wait, do I have to move each one individually, right? Move 0 down, move 0 down, move 4 down, move 4 down, move 4 down. One more. Okay. Ah, so when you stop it, it stops displaying. Interesting. Okay, so step. And then 4. Oh, I think I see. Do I see? So 004 is enough to display a red pixel in 00. When you add the second 4, I don't really understand why that results in a pixel next to the first one. So is it just the number of 4s? Essentially, every pixel after the starting coordinate. I see. Okay. So it has to draw in a straight line. Okay. Now I'm with you. Now I'm with you. So it's not start and finish. It's just every individual square next. Yeah. Okay. So in that case, you could copy this any number of times and just get a longer red line, right? We could move a different color down, for example. Yeah, I see. Okay. And you could change any one of these to... Yeah. All right. I'm sure lots of people have built all kinds of things using this. Okay. All right, cool. So I need a utility that continually outputs white until it fills up the screen, right? Do I even need to send a terminator? What happens if you don't? Interesting. So if you don't send the terminator, it doesn't stop. I don't think I expected that. So why? I guess it just assumes it restarts at the bit after the previous pattern finished. Interesting. Whereas if I terminate it, all right. So how many, what are the dimensions again? 30 by 18. Whoops, wrong way. Okay, so I need a counter that outputs 18 things. Do I need to count exactly how many squares I'm going to display? A counter that counts 18 things and a counter that counts 30 things. Okay, let's have a think about this. We have a row counter and a column counter. So let's say we're at B. Move 30 ACC. Save. Move 18 ACC. Loop. Jump equal to 0. Next. Swap. Jump equal to 0. B. Sub 1. Swap. Jump equal to 0. L. I'm going to run out of room, aren't I? Jump equal to 0 next. Sub 1. Move. What's the white code? 3. 3 down. Jump L. And then this would be move up, down. This would be move 0 down, move 0 down, L, move up, down, jump L. I guess. Well, that's a start. I don't think it's quite what I had in mind. Oh, we have to increment. Right, we can't do it that way. I didn't realize that you couldn't just skip to the next line. It doesn't wrap. There's no such thing as image wrap. Okay, move up, down. Okay, cool. Interesting. So you have to increment the XY that goes at the start, or at least you have to increment the Y. Yeah. How do I do that? I mean, I know how to do it, but how do I fit it in? I'm going to have to use multiple boxes. It's quite tempting to I'm always tempted to say that you just have one box that all it does is do the line counting, but and then feed that into the next box, which just does the outputting. Interesting. So I imagine we'll probably use the same pattern again. Let's just try and cram it into this box just to see where the failure point is. So we have to move 18, yep. And then we have to move sub 1. What happens if you start at the bottom? Does it matter? Because that would be quite convenient. Move 0 down and move ACC down and then go to the loop. I can't imagine that'll do anything useful. Oh, you can start at the bottom. And that's all we get. All right. Interesting, though. Okay, so you can start at the bottom. That's good to know. Yeah. So that determines our original coordinates. I wonder, could you just delegate another box to do the rest of it? Surely you could, right? Yeah, let's try that. Let's go jump equal to 0 is next row. And then next is actually, hang on. Undo. All right. We're not going to be doing this loop. Next is swap. Oh, actually, we'll just keep, we don't even need a loop. We can just swap. I don't know if we need jump equal to 0B, but it's fine. sub 1, swap, jump equal to 0. So hang on, we move the first two numbers down, then we swap them. Actually, we don't need to swap them. We do need a loop here though. Sub 1, move 0 down, move ACC down, jump equal to 0, B, no. Just this. And actually we don't even need the 30. This is just a row counter. Sub 1, move 0 down, move ACC down, jump equal to 0 left. Yeah, cool. So that's our row counter. Then move up ACC, swap, move up ACC. Actually, can't we just... move up, down, move up, down. That gets our coordinates out, and then we go into our loop. Move 30 ACC. And then our loop is move 3 down, sub 1, jump equal to 0 end. Actually, jump equal to 0 B. Yeah. Gonna have to stop and cook tea in a minute, but I really want to get this. Jump equal to 0 B, jump loop. I think that's actually close. Oh, and we need to send the -1. So jump equal to 0 end, and end is move -1 down. Yeah. All right. We get one line. Damn it. Okay, we need to watch what happens. I just need to run it through until the end of the line. Okay, we got move -1 down. Okay, we got -1. Move ACC down. 17. So we got 0, 17. That's X and Y, right? I guess it doesn't work if you start at the end. Maybe I've misunderstood something. Starts at 0, 0. Maybe you don't send the terminator until you're actually... but that doesn't make sense. All right, let's just experiment with some hard-coded stuff. So instead of this, we're going to go move 0 down, move 17 down, move 3 down, 3 down, move -1 down, move 0 down, move 16 down, move 3 down, let's try that. Interesting. Oh no, that's right, because it's double height. So if I do that one more time, yeah, that's fine. So was I just not changing the value correctly? Sub 1, move 0 down, move ACC down, jump sub 1. Should work. Maybe I shouldn't try and write, maybe this should be 29 or 30 because it's probably 0 indexed, right? But it wouldn't matter because it's just counting. I don't know. Let's just see if this number is coming down correctly. Oh, it's not. It's staying at 17. Why is it saying it's 17? Oh, I'm dumb. Jump equal to 0 L, but we just want jump L. There we go. Hey. I think it's gonna work. I hope. Yes. All right. Everybody got the same. And cycle count at least. Okay, cool. Okay, return to the segment list. I'm going to just check what the debug is for the next one, and then I'm going to finish. Well, we're getting through it. I'm encouraged. Oh, look at that. Nice. All right. Debug. A dream about a tremendous circle of eyes pointed inward at the first creature of the world. Stranger and stranger dreams as I get older. Oh man. He's losing it. He's absolutely losing it. Is it the machine doing it to him? I don't know. All right. That's where we leave it. And I need to find someone to raid, even though there's only 2 people watching, but that's fine. I welcome you. Exodrifter's learning Emacs. You poor thing, Exodrifter. Grumbler Pugs, we raided last night. Oh, Evan's streaming. Nice. We'll
slow, it's just not. My preferences. What is wrong?
We'll jump in there.
Okay. First of all, I'm not a girl. I'm assuming you're a man, so there's kind of no hope in this situation. So I'm kind of a straight guy. Entity ID. Fuck you, man.